Okay, so today we're going to look at a question from paper 2 of thermal properties of matter. This question comes from 2011 paper 2 A, section A, question 3b. So let's read the question together. The heater inside the dryer supplies thermal energy to the air at the rate of 2500 watts. In 1 second, 75 grams of cold air at 20 degrees enters the hand dryer. It emerges as hot air. The specific heat capacity of the air is 1.1 joules per gram per degree Celsius. So the first question is calculate the temperature of the hot air that emerges. So again, this question is a question on heat or energy transfer. So the energy transfer is between the energy supplied by the dryer and the energy absorbed by the dry air. So the cold air. So what happened is that again it's a question on the conservation of energy, where energy is supplied without any loss from without any destruction or totally loss of energy. It's just perfectly transferred from the dryer to the air. So let's look at the calculation. So the first of all, we need to know that the energy supplied by the dryer is given by the power multiplied by the time, while the energy absorbed by the air is given by mc delta theta. So when we put these two together, we are looking at only the calculation for 1 second, because this question is only talking about the energy, the change of temperature of 75 grams of cold air, which is the amount of air that enters the dryer in 1 second. So the power is 2500 watts multiplied by 1 second is equal to 75 times 1.1 times theta minus 20. Why is this theta minus 20? Very simple. This is the final temperature, which we will denote as theta, and this is the initial temperature, which is 20 degrees. So the change in temperature, which is delta theta, will be given by theta minus 20. Alright, so why do we use 75 grams? Very simple, because we are considering 1 second, so we only consider the mass that goes through the heater in 1 second, which is only 75 grams. And then the next thing is that why can we use grams and 1.1 for m and c when we know that this is not SI unit? Whereas again, we have to look at this. The mass is in grams, the specific capacity is also in joules per grams. So what happened is that these two actually are in the same unit and the grams cancel off. That's why you do not have to convert to kg. Alright, so if you manipulate the equation around, you'll find that the answer is 50.3 degrees. So the next question that is being asked is, explain why the water on the hands evaporates rather than boils. This question is actually quite straightforward. The first thing we need to know is one of the ideas of the difference between evaporation and boiling. If you evaporate, you know that it happens at any temperature of the liquid, but when you boil, it only happens at boiling point. So let's look at the final temperature again. The final temperature of the dry air that is coming out from the dryer is 50.3 degrees. So this air is going to hit your hand. So obviously this temperature 50.3 degrees is much lower than the boiling point of water, which is 100 degrees. So because of that, the only possible means where the water converts to vapor is through evaporation. So I'm not going to write in full words, but this concept is enough for you to write yourself. So that means that the temperature is below the boiling point of water, so it cannot boil, it can only evaporate. Okay, so that's the answer for part B.